Day 2, we are going to review the idea of domain and range. We'll take a look at independent and dependent variables, and we're going to skip the describing graphs and also the assignment for this lesson in your packet. Instead, we'll be doing a Desmos activity. So fill in the blanks below. Domain is all the possible blank values, otherwise known as the independent variable, and that would be x values. So let me write that in. So domain, x values, whereas the range is all possible y values, also known as the dependent variables. So below, let's find the domain and range for the following relation. So we have a set of ordered pairs here, so a bunch of coordinates. What would that look like in a table? So in a table, that would be 1, 3 for our first coordinate, 4, 6, 2, -5, and -2, 4. Remember, in an ordered pair, x comes first and y comes second. So when we take a look at domain and range, domain is all possible x values. So here's the domain of this graph right here. And then the range is all possible y values. So here's the range right here. And so how we might write domain and range for this right here, I'm going to write it below. The domain, and we're going to write curly brackets right here, is 1, 4, 2, and -2. So that is, those are all the x values in this relation, so that is the domain. And range is all the y values. So in this case, again, I'll just use curly brackets for a range right here. It's 3, 6, -5, and 4. So that's what domain and range look like when it's just numbers. We can list the numbers. Again, domain x values, range y values. We can put these coordinates in a mapping diagram, and all that is a table but with ovals and arrows. So let me show you what that looks like. So in a mapping diagram, again, let's put our domain right here. Now I'm just going to take the x values in our table and put them in an oval. And then I'll take the y values and also put them in an oval. And a mapping diagram just has an arrow pointing from the x coordinate to the y coordinate. So here is what the mapping diagram looks like for that table below. So essentially a mapping diagram is just a table with ovals and arrows connecting the x and y values that are related. And then of course we can graph these coordinates. So 1, 3, we would start at the origin, 0, 0, and go over 1 up 3. Go over 4 up 6. 2, -5 is right here. And then -2, 4. And we talked yesterday about domain and range and how in a graph you can tell if it's a function. Have we talked about function? No, we haven't. Sorry, we have not talked about functions. So here's what it looks like for your mapping. For your graph, if we take a look at the coordinates. Okay, so what we did on day 1 of this unit, so yesterday, was finding the domain and range of graphs. And so we're going to review that idea today, and this will be what the Desmos assignment is on. It'll be a bunch of graphs. Can you find the domain? Can you find the range? So let's take a look at our first graph right here, and let's find the domain. And recall from the first lesson that for domain, we want to know how far left and how far right the graph goes. So here's the leftmost point and here's the rightmost point. Domain is x values, so we say the domain is between -4 and 5. And we said that with inequality, so we said -4 is less than or equal to x, which is less than or equal to 5. And again, that's the mathematical way of saying, hey, x is between -4 and 5. And since the dots are closed, we can put the equal sign because x can be -4 and x can be 5. And so the equal sign just says it can be those coordinates as well. All right, range is how low and how high does our graph go. So in this graph right here, the lowest I see is 3 and the highest is 7. So for range, we say that the y value is between 3 and 7. And again, since they're closed dots, we can use the inequality less than or equal to. So 3 is less than or equal to y, which is less than or equal to 7. And that's our range. All right, let's talk about this funny looking, looks kind of like a helmet or a UFO shaped graph here. Again, domain is how far left and how far right. So this one looks like -7 to 7. So we say -7 is less than or equal to x, which is less than or equal to 7. For the range, that's low to high. And so our lowest point here is at -3. is less than or equal to the y value for range, which is less than or equal to 4. And so there's the inequality for range. Let's take a look at two more, and I'm going to change one of them slightly because we talked about having like an open circle. So let's put an open circle on this graph right here. I'll put the open circle right here. Okay, so for domain and range, again, it's how far left and how far right. So for a domain for this graph, we'll say 1 is less than or equal to x, which is less than but not equal to, because of the open dot, our graph would approach that value, but it can't quite get in because there's that fence around it. And so we would say it goes up to but doesn't include 5, so less than 5. So for this graph, if that green dot had been there, an open circle, we would say that our graph is less than 5, but not equal to. Let's do range for that graph. Again, low to high. And again, I probably should have, maybe I'll change it again because for range, we're looking at low to high, and it's confusing if we have a closed dot and an open dot there. So I'll make them both open dots, which would change this inequality. So that was open dot for both. We'd say 1 is less than x, which is less than 5, which means that x is between 1 and 5, but doesn't include them. All right, let's do range then. So range is low to high, and again, I made them both open dots, so we can do the range. And our lowest point is 1. It's a closed dot. And then our highest point is 5, and so let's say less than 5. So again, I did make that open dot for both, just so we can put the less than sign there. Okay, and then we looked at situations on Monday. If there's an arrow, what happens if there's an arrow and your graph keeps going? So for this one, our domain is how far left and how far right. Notice there's an arrow, so it does keep going all the way left and all the way right. So if it hits every value of x, we say that our domain is all real numbers. So I put colon, but you could put like an equal sign too. I'll put the colon there. All right, so all real numbers just means it keeps going forever in both directions. So all negative numbers, all positive numbers, anything on the number line, it would hit. For the range, though, there is a minimum value, and that minimum value is 2. So we say y is greater than or equal to 2, or you can say 2 is less than or equal to y. Typically, when it's just one letter, I like to put y first, so here is how I like to write it, but the way that we've been writing it, we like to put the smaller number first, so this way might be more like what you've seen us do in class or for the YouTube videos. So 2 is less than or equal to y, which means y is greater than or equal to 2. Okay, so that is kind of our quick review on domain and range. If you want to see more examples, of course, you can go back and watch the day 1 video, which has many more examples of domain and range in a graph. And so the last thing for today before we get to our Desmos activity will be independent versus dependent variable. Independent variable is the same as domain. The dependent is the range. On a graph, the domain is the x values and the range is the y values. So if we take a look at it in a graph, again, here's x, here's y. Here's your independent, would be on the x-axis. And then the dependent would be on the y. So here's the dependent. Okay, but here are some kind of analogies that we take a look at when we're talking about independent and dependent. So just things to help you kind of process what these mean. So independent is what you do, and dependent is what happens. Independent is the input, dependent is the output. Independent is like saying the cause, where dependent would be the effect. And independent is like saying what happens before, where dependent is what's after. So, for example, I'm not going to go over all of these because the main goal is domain and range today. But for independent, dependent variable, an example is, okay, we can take a look at cell phone bill, depends on minutes used. Okay, so we would say, all right, cell phone minutes, cell phone bill depends on how many minutes you use, unless you have unlimited minutes used. I'll do one more. So our dependent is right here. Our independent is right here. So in a graph, this would be on the x-axis. All right, let's do another example. How about grades on your test? What does that depend on? And that typically depends on grades. Your 6 weeks average. I guess I don't like that. I would say how much you study, so I'm going to change this one. So how much you study your grades depend on that. So I would say grades depends on how much you study. All right, so those are just some examples of independent, dependent variable. Dependent depends on the independent. So there's more. Typically, if you're in class, we would do like story problems, but we're going to skip that for today because, again, the goal is domain and range. And so your assignment will be the Desmos activity, which I will put on Google Classroom. So there'll be the link there. And so for your assignment, do the Desmos activity and get that done for tomorrow.